What's up, guys? Welcome back to another video. So today we're going to take a break from the Mustang. As you can see, it's not here. Daughter's in town with it. We're going to do a kind of a more of an explanation video because I'm getting a lot of questions on this video right here.
Loving ass. Let's check the bank account. Nope, never mind. Fuck that shit, it ain't a cute amount. I cut loose when they go pop the goose. Tab storage, you make that too. I don't follow rules. On my tippy toes, ducking birds like I'm Fabio. It's easier than needy, meeny, mighty mo. Have you heard the news?
And I feel like since, this video has blown up so much and it has gotten, I've been, like I said, getting tons of questions, I'm going to do more of an in-depth video on what exactly to look for, what's going on, and just kind of answer some questions that I've gotten repeatedly on the short that I made involving the IWEs on the F-150. So if you're new here, IWE is integrated wheel ends, and that's what's on the F-150s. I think they started them in like 99. And what that does is it uses vacuum to pull the hubs or the axles out of the hubs to where it's supposed to be better on fuel, but I feel like it's just more of an issue down the road. I've already had dealt with stuff on this one, dealing with those, and like I said, when it happened, I was a quick fix, temporary fix for right then, and then I got it taken care of and all that, and I showed how to do that. So what I'm going to do now is I'm going to go in more in depth and actually show you what it does, what to look for, and how you can properly diagnose where your issue's coming from. So let's go ahead and hop inside real quick because it's hot, and I'm going to explain the integrated wheel ends to you a little bit better, and then we'll get started on the truck. All right, now that we're out of heat for a minute, I'm going to explain to you IWEs or integrated wheel ends. So what that is designed to do is whenever it's engaged, like I said, it runs off vacuum. So the axle will actually be pulled out of the hub to where the wheel can spin freely without adding excessive wear and tear to your axles or anything like that. The way that works is the axle has teeth on it and the hub has grooves. So basically teeth go into the groove, but whenever you lose vacuum or you turn off, you engage four-wheel drive, because that's mainly what it's for. So when you engage four-wheel drive, that axle slides out and locks into those teeth, so that when your axle's putting power down, your wheel's turning as well. What happens with the solenoid going out or having a vacuum leak is basically your vehicle can't decide what it wants to do. Is it engaging four-wheel drive? No. What it's doing is you crank the truck up, the vacuum pulls the hub or pulls the axle. So you're driving down the road 50 miles an hour, and as it's sitting there spinning, like the grooves in this hub are designed to fit precisely around the teeth that are on the axle. So as you're sitting there spinning at 50 miles an hour, this one's sitting at 0 miles an hour. So you lose vacuum. Well, now you've got this, and this is trying to get in there. And for lack of better example, like I said, it's your hub sitting there spinning, and this axle is trying to engage. That's where you're going to get the grinding sound, the metal on metal, everything like that, is because it's trying to get in. Now, what usually happens when you have a vacuum leak is it'll go in, it'll try to go in, it makes the noise. Well, then you get into acceleration or something like that. It pulls more vacuum. It pulls it back out, so then it goes away. So you hear it, and then it quits. What that is it's pulling more vacuum, and like I said, it's intended to stop, to stay right there. But since you have a vacuum leak or your solenoid's not working, it's easing its way back out. So you're getting that intermittent because it's constantly trying to get in. So what happens, the fix that I showed on the other video, is you can unplug that. And I'm going to show you in this video as well. Like I said, I'm going to go ahead and break everything down for you. You can unplug your solenoid. What that does is it cuts the vacuum completely off to where that axle just slides out into the hub and it stays there. And wheel spins, the axle's spinning the entire time. So on both sides, like I said, it's gonna run, your whole axle's gonna spin, which, like I said, or like I'm gonna explain, Chevrolet, Toyota, Dodge, they all do the same thing. They're all designed, they spin, they're just locked in constantly. Does it cause more wear and tear? I mean, maybe in the long run, I don't know. I mean, I've got a bunch of miles on mine and whatever. I know it's completely different, but like I said, so theirs is constantly spinning. Ford did it differently to where, to acquire better fuel mileage, less rotating mass. So instead of spinning the entire axle, the differential, the front drive shaft, all the way to the transfer case, you're cutting all of that rotating mass out to where it's just the wheels. So I guess on paper, yes, it would save a little bit of fuel, and maybe if my truck's not like way up in the air, yes, it'll save on fuel, but honestly, I didn't notice the difference. I really didn't care. So with that being said, can you run it with it disengaged or with the vacuum turned off and the axle fully engaged? Yes, you can. Because like I just said, I ran it for 2 months, 0 issues. I finally just decided, hey, let me go ahead and just fix this and put it all back together. But other than that, you're not gonna hurt anything. And I know that was one of my biggest questions that I received was, I don't want to damage anything further. We are not, because instead of having that intermittent trying to engage, it's just fully engaged all the time. It doesn't affect your turning radius. It doesn't affect parking. You're not binding your four-wheel drive system. Nothing. You are serious. You are just doing what Chevrolet, Dodge, and Toyota have been doing this whole time. Ford just wanted to be different and set theirs up to where, like I said, it just less rotating mass. So now that we've gotten in here and we've cooled off a little bit because it is ridiculous hot outside, let's go ahead and hop back outside and I will show y'all in further explanation what exactly I'm talking about. So let's get outside. So now that we've got that explanation out of the way, what I'm going to do is we are going to jack the truck up. I'm going to show you the exact difference of what it actually does and, like I said, what to look for, and I will simulate everything with Solenoid, show you where that's located, all that. So first things first, let's go ahead and get this thing up in the air. Okay, now we got the truck in the air. So basically what they do, like I said, the truck's off, meaning there's no vacuum being pulled. So we turn this right here. Okay, we are turning, so I can get to where y'all can see it better. Okay, there's the axle right there. Everything is turning all together, just like that. There's no vacuum being pulled, meaning the axle's all the way out into the hub, interlocked to where, like I said, you spin this, you spin the axle. So now what I'm gonna do is I'm gonna crank the truck up, and what we'll do is we'll show you the difference. Once you crank the truck up, it builds up vacuum and it pulls the actual axle out. I'll show you what that does, and then I'll explain to you why you're having the issue that you're having. Now that the truck's running, let me show you the difference. Okay, as you can see, right here, the truck's running. Now look, the axle is not moving. Everything from here out is stationary while this spins. So that is what your IWD system does. So now that we got that covered, let's go ahead and we'll get the sun out of there. We'll open the hood and I'll show you where to look for the solenoid that controls the vacuum for that specific thing. So let's go ahead and get this open. All right. So when you open up the engine bay, right here behind the intake, this thing right here is what controls your IWD system. A lot of times, this is what's going to fail. It's going to cause IW hubs and everything to start trying to engage. So what happens with that is, as it's trying to engage, it's trying to push the axle back out to the hub. The hub's running down the road, spinning, and it's got teeth, like I said, where it locks in. So what's happening is that hub is spinning, and your axle's trying to slide out into it. So it's catching, trying to get into the grooves. And a lot of times the reason it's intermittent is because as you're applying throttle, anything like that, your engine's pulling into a vacuum. So it's trying to steadily pull the axle back, but either the solenoid's going bad, or your vacuum lines have a hole, pinhole, something like that, or there's not, the seal is bad in here. So what happens is that it's pulling the vacuum, but it's still allowing it back out to where you're going to get that grinding sound. So what I'm going to do now is I'm going to unplug this with the truck running, and I'm going to show you that it does engage everything. And then I'm going to answer the second most seen question that I've had on that video that I showed earlier. So let's go ahead and get this unplugged real quick. So as I said before, here's your solenoid for this. Pick this up. Just like so. Hard to do this one-handed. There we go. Alright, now, as you can see, it is disengaged. So with it being disengaged, like I said, there's no vacuum being pulled. So let's go ahead and hop back down here and see if that's what's actually happening. See it? The axle is back to spinning with the wheel. So, with that being said, we're going to kind of jump sideways to the other questions that I have. Will this damage your drivetrain? No, it will not. All it's doing is it's setting these trucks up to work just like the Chevrolets and the Toyotas, all Dodge, all that stuff. All you're doing is now everything is fully engaged. Your front axle is going to spin. Your differential is going to spin. The drive shaft going to your transfer case is going to spin. But that's where it stops. No, your truck's not in four-wheel drive. You're not running around in four-wheel drive. You're not preloading your suspension, or not suspension, your drivetrain, turning, parking into parking spots, anything like that. You're not doing anything. Because again, the motion stops at the transfer case. So, will this hurt anything? No. Like I said, I drove around with it for, I want to say, I think it was like 1 or 2 months. And honestly, the fuel savings that Ford, did this for was maybe cents on the dollar, if that. Like, I didn't notice anything. I mean, which I'm also not out here like looking for, fuel miles, seriously. So, with that being said, I'm going to leave it unhooked. I'm going to set the camera up. I'm going to do some sharp turning just to show you there is nothing going in a bind. You're not going to hear anything popping. You're not going to be, torquing anything in your drivetrain that can cause damage. So, go ahead, put the truck back on the ground, set the camera up. I'll do some sharp turns, pull it up into my garage, whatever, where you can see that I can turn it lock to lock, no issues. Then I'll plug it back up, and I'll show you the same thing. I'll show you there's absolutely no difference. So let's go ahead and put it on the ground and get to this next one. I also wanted to show y'all that with it being engaged, this goes back to the four-wheel drive kind of setup. It's not locking anything together. So when I go over here and spin this wheel's not going to do anything. So I'm going to set you down. I'm going to go there and I'm going to spin this one. I'll come over here and spin this one. I'm going to show you that they are not anywhere interlocked together that will cause any kind of drivetrain issues. So let me go ahead and show you that real quick. Go ahead and get both of them in the screen. Okay. So with that being said, I mean, I think the second biggest question was, you know, hey, I don't want to run around four-wheel drive. That right there shows you that it's not actually in four-wheel drive. It's just the front section is hooked to the wheels now. So now we can put it down. And again, just so y'all can see that I did not change anything. Ooh, Lord, the sun. Still unhooked. Keep y'all on live so you can see that it's not. There you go, just like that. All right, I'm gonna put you down. Show you what I'm talking about. As you can see, like I said, I mean that's full lock right there. No binding issues, anything like that. So now I'll back up and I will open the hood, plug it back in, and we'll do the same thing. But I mean that's mainly going to answer your question right there, is the fact that it is engaged. And I'm hoping in this video you can see it turning as I'm pulling in. But it is engaged, but there's no binding issues because again, it's not in four-wheel drive. So go ahead and hook it back up, put it in four-wheel drive, and then I will turn it just so y'all can see the difference. How about that? Just go ahead and just experiment away with this stuff. So let me go ahead and do that real fast. Again, provide the proof that we are actually hooking everything back up. There we go. Now, there we go. See, right there, everything is hooked back up. All right, now go ahead and back up, and now engage full drive and pull forward. I know it's kind of hard to tell from the outside, but I mean that is as sharp as I can turn without it trying to lurch where it's binding together in four-wheel drive. So I hope that answers your question about, you know, hey, I don't want to drive in four-wheel drive, because you can't turn into parking spots, you're not in four-wheel drive. That four-wheel drive shows, I mean, I couldn't even get back to the same spot in the garage. So, I hope that answers your question on that. So, with all that being said, I hope you stuck around and kind of maybe learned something today. Like I said, this was all news to me as far as everything goes. You can do the IW delete kit, which I had considered, but once I replaced my solenoid, I've had zero issues with it. So I just, run it like it is. I hope this video was helpful and explained a lot. And if you have any questions, be sure to hit me up in the comments. I'm going to link this video to the one that I showed earlier. That way, if you're coming here from that video, from watching it now, because I know it's getting a lot of traction here lately, that way I can answer your questions for you, in a timely manner. If you like the content, like I said, like, comment, subscribe, and catch you on the next one.